Welcome, thank you for being here. This is our talk. Oops, I leaked it again, how we found PII in exposed RDS snapshots. And this is Brittany. So who am I? Very quick. My name is Doron. I'm a senior cloud researcher working for Mitiga. I have experience of around 9 years in the industry as an instant responder and threat hunter. And I prefer animals over human. And I'm also Israeli. Usually I wouldn't mention it, but I guess that most of you know that right now Israel goes through a horrific time. And there is a war going on in Israel that started 11 days ago. And I wouldn't like to use the stage for any political message, but I would like to honor the memory of the victims with a moment of silence. And I would appreciate if you could join me for that. Thank you. Okay, now we can really start talking about cybersecurity. So what we're going to have today, we're going to talk about RDS. We're going to talk about what is RDS, what are RDS snapshots, what is RDS public snapshot, and what is the problem with public RDS snapshot. We are also going to talk about how attackers exploit public RDS snapshot in the wild and how easy it is to them to get information from those snapshots. And we're also going to see the process of our research that we've conducted and what we did in order to get our hands on valuable information that shouldn't be exposed. Then we are going to, oh my God, PII, we're going to show you some examples and some numbers. And at the end, we would like you to have some action items after this talk. So some detection and mitigation steps that you can take later to employ in your organization. But before, I would like to show you some examples. So we said that we found millions of PII records on public AWS RDS snapshots, and these are just some of them. What we can see are examples of tables that we found, tables out of those databases. And what we can see is username, user password, user email, user gender, birthday, email, phone number, marital status. We can see ID numbers, a token, administrative password, and more and more and more and more examples. So let's deep dive into the introduction. So what is RDS? RDS is a platform as a service provided by AWS. This is a database as a service. And its main goal is to simplify database management in the cloud. So instead of your team to do all the tedious tasks of software patching or hardware provisioning and other things, they could focus on the development of their application, for example, and leave all the tedious tasks for AWS to do. Among the features, we can see multiple database engine support. So RDS supports MySQL and Postgres and others, MariaDB and more. High availability, and what is important for our talk today is that there are automated backups and point-in-time recovery, which are the snapshots. RDS is a very, very popular service, and a few years ago, Stack Overflow came up with research that shows the incredible growth of Amazon RDS among companies. A little bit about what are those snapshots. So a snapshot is a point-in-time copy of an Amazon RDS database. So the database is the instance itself with the data, and a snapshot is a copy of it, which is stored in S3. What is important to know about those snapshots is that they can be taken either manually or automatic in a scheduled frequency. A backup is actually a backup of the entire DB. So a snapshot is not just an export of the data that is stored in S3 or some tables. It's the entire DB, including the metadata of the DB, which is important, and we will talk about it later. And also, those snapshots can be shared. They can be shared either within your organization between different accounts or externally to other accounts within the AWS premises, or even to all AWS accounts. And when this happens, this is basically the public RDS snapshot. So you might think, what could go wrong? Let's say you or your colleague, you have permission to create a snapshot, and you could publicly publish it. And let's say someone did a mistake and published it for, let's say, 5-10 minutes. What could go wrong? Let's say they discover after 5 or 10 minutes that they did it. They take it down, they make it private again. Do you think anyone would go to their security team or to their CISO to say, hey, I did a mistake, I left it open? I don't think so. And why? Why is it important? First of all, those databases can and are contains sensitive data like PII, like secrets, something that we saw quite a lot in our research, secrets that to application that could be used later for further exploitation. Publishing snapshot, and we will see that publishing snapshot to public, even for a short period of time, couple of minutes, could expose them. And there is a major lack of visibility into unauthorized action over those snapshots, which we are also going to talk. But first, let's see how an attacker could abuse it. So adversaries can easily clone publicly available RDS snapshots using only 2 API calls. They would need to use 2 API calls in order to find the snapshot and clone it to their premises. Try to think about traditional scans. So this is kind of a scan, right? Try to think about traditional scans, like network scan, port scans, or vulnerability scans. These are used by attacker to gain better understanding of your organization. And this is one of the initial stage of the attack kill chain. With this scan of public RDS snapshot, if someone gain access to a snapshot with valuable information, they kind of skip the whole kill chain and directly have access to the data itself. From there, they can use it for ransom or publish it to make sabotage. Let's see how we can do it, if it works. Okay. So what an attacker would need to do is to use the describe DB snapshot API call with the include public flag and to select a region. Now we will see an output which includes all the public RDS snapshot in this region, along with the details of each of them. Now what the attacker would need to do is to choose the DB snapshot identifier, which is a unique identifier for the snapshot, and to use this identifier as the argument for the next API call, which is a copy DB snapshot. They would need to mention the target DB snapshot ID and the region. And a few moments later, they have a copy of the snapshot in their account. 2 things that are very important to know at this stage is that now the attacker, they have a copy of the snapshot in their premises, in their AWS account. It doesn't matter what you, as the owner of the DB or the owner of the original snapshot, do with those resources. Let's say you delete them or change anything, it doesn't affect this snapshot. Now he has the full, complete copy. Another thing that is important is to see that there are details here, and those are the details of the snapshot, but some of those information are the details of the DB itself, the original DB. For example, you can see the creation time of the DB, and you can see this DB was created in 2015. And also we can see the master username. The master username is the username of the DB. In this case, it's root, but it's important to understand that sometimes the name could be indicative of the company that uses this DB. For example, an opportunistic attacker, what they can do, they can scan the whole public RDS snapshot available in any region or in all regions, and try to look if the master username has any name of a company, for example. And then instead of targeting a company, they can use this and say, okay, let's explore this. Let's see if there is any valuable information and use it against this company. What we what we did. So we used an AWS native technique that uses AWS Lambda function, step function for the orchestration of the code, and Boto3 for the automation of the API calls. And our main goal was to do exactly what I showed you now, but to do it at scale, which means every day to all regions to be able to clone all the public RDS snapshot and quick. The speed is very important here because we were trying to look for snapshots that were exposed by mistake just for a few minutes. So what we did, we built two processes. First one on the left-hand side, what we call the active scanner, and on the right-hand side, what we call the offline extractor. As for the active scanner, what we do, it runs every 5 to 10 minutes. It's configurable. It scans for all the DB snapshots that have been marked as public at all regions, all available regions. Then we iterate through those regions. And for this, we use the describe DB snapshot API call. And then we iterate through all the regions and we clone the DB snapshot to our premises. We also, at this stage, we maintain a state file that tells us whether we already cloned this snapshot, just for the sake of speed. So we don't clone snapshot that we already have. For this, we use the copy DB snapshot API call. At this stage, this is an example of our code. At this stage, we have the DB snapshot in our AWS account, and now we want to create databases out of them. So what we do, we list all the cloned RDS snapshot that we have in our premises. We get the snapshot ARN, which is a unique ID for each snapshot. We create a DB instance out of it using the restore DB instance from DB snapshot API call. And then we automatically extract some information around this DB. This information includes the DB schema, which are the table names and the columns of within this table, and some information, some data from those tables, and we store it in S3. And at this point, we have all the information we need to perform further analysis to understand if there is any valuable information there. And right after that, we delete the DBs from our AWS account to cut the costs. A little bit more about what we do in the extract and analyze part. So as we said, we use an automated process that help us to highlight those DBs and tables that are important for further analysis. What we do, we extract first 10,000 rows from each table, which give us a sense of what there is in this table, the name of the columns, which is the table schema, and the table name. We store it in S3, and then we filter out what is the ones that are not important for us. To do so, we filter empty tables. We don't want those. And we created a list of keywords that are related to PII. And we search the table columns names against this list. By that, we dramatically reduce the number of candidates that we would later need to analyze. Now let's see some juice, the information itself, what we found. Before we dive in, the research that we've conducted was over a period of 30 days, and this is what we saw. One example is car rental agency DB. The DB was created on March 22, and the snapshot was taken on August 22, 5 months later. And this is what we see in this table. This is the table of orders, and what we can see is the name of the same sales consultant, when the car was rented, what is the model of the car, the first name of, and the first and last name of the person that rent this car, their phone number, their email, and also why they did it. And we can see some funny occasions like marriage or divorce. But we had even more interesting tables. Dating app DB. What is important to know that this DB, this snapshot, was exposed only for 4 hours. In these 4 hours, we managed to get this the snapshot, create a DB out of it. Then they deleted it, but this is what we saw. So this DB was created in 2016. The snapshot was taken 6 years later, 2022. And what we see here is the user tables. What we can see in the user table is the username, the user password, the user email, gender, birthday, ethnicity, country, image, description, how many times they were signing in, and more metrics about each user. And this was, it wasn't even the most shocking table in this DB. The most shocking table was the messages, which were not encrypted. And we were able to find all the messages that were sent between users in this dating app, and try to think, this is crazy because now we know details about the users and what they send to each other. So from these two extortion, it's very easy. I hope this dating app doesn't work anymore. These were some examples. Now let's talk about the numbers. So total numbers of DBs of snapshot that we found during these 30 days was 2,783. Most of them came from US East 1, which is the default region for AWS, and so it makes sense that most of them would be from there. And in terms of the engine of the DB, 78% were MySQL, but we can see representation for other engines like Postgres, MariaDB, and more. So what we did in order to get the interesting snapshot. So we have 2,783 snapshots. That's quite a lot. We want to reduce them so we can, as we said, we would like to focus on the one that are interesting and to give you the information about this dating app. So what we did was, first of all, to filter out all the accounts that published more than 5 snapshots over these 30 days of research. We found out that there were quite a lot. We found 2,059 snapshots that were published by those spammers accounts. And we assume that this is part of their workflow to publish those snapshots. Later on, we filter out for boring keyword in the snapshot name. Boring keyword would be keywords that indicate it's supposed to be public, like public, test, demo. We took those out, and we left out with 650 interesting snapshots. From now on, everything that I show you is related to those 650 snapshots. So some metadata-based insights. Here we can see a graph that shows us the number of snapshots per day, which means for how many days each snapshot was exposed. This is quite interesting because we can see on the right-hand side, we can see that about half or a little bit more than half of the snapshots were exposed for the whole period of the research for 30 days. And there are 2 possible reasons why they were exposed. First of all, they were supposed to be public, so that makes sense, or they were left, forgotten, exposed. On the left-hand side, we can see about the HDRF, and we can see that between 0 to 2 days, we had around 400 snapshots that were exposed, with 200 of them exposed less than 24 hours. Some of them were exposed for few hours, few minutes, up to 24 hours. And we believe and we know that those are the ones that are the most interesting because they were exposed by mistake again. Another interesting graph that I would like to share with you is snapshot by their DB time creation. So as we said, we have the DB instance and the DB snapshot. The DB instance is the instance itself. And once you copy the DB snapshot to your AWS account, you also get information about when the DB instance was created. What we can see here is that the vast majority of the DB instances were created during these 30 days. And these are probably not interesting because these are new DBs. Maybe it's some testing that the company does. They create a DB, they create a snapshot. We wouldn't like to focus on those, but we can see that there are more than a few that the snapshot was taken during the 30 days of research, but the DB instance was created long ago. We can see example of DB instances that were created 9 years ago in 2014, 2015, but the DB snapshot was created during these 30 days of research. And why is it interesting? It's interesting because those snapshots have higher chances to contain valuable information or at least real data, and these are possibly not have nothing or not interesting data. And again, back to the content-based insights. So we created a list of PII-related keywords, and we searched the column names, the table, the column within the table that within the DB against those keywords. And we found that there are 171 different RDS snapshots with 5,700 interesting columns that we would need to now start exploring. So this was the process that we went through in order to find those snapshots that are interesting. Now you might ask yourself what you could do in order to detect this threat and to mitigate this threat. So one, like CISO or incident responder or anyone from the security team could ask himself, how can I know if someone copied my public snapshot? So apparently you can't. We mentioned this major lack of visibility within AWS, and this is something very interesting that we found during the research. If you take your snapshot and you publish it as public, make it available to all AWS accounts, from now on, this is your own resource, but as for AWS, this is not really your resource, because if someone else from an external account do anything to this snapshot, for example, copy the snapshot or create an instance out of it, you won't be able to know. But we know that AWS knows that there is a risk here. And why do we know it? Because in other services within AWS, in EC2, for example, if someone publish an EC2 volume, which is an EBS, make it public, and someone else from an external account do anything to this snapshot, this EBS snapshot, for example, copy this EBS, public EBS to their account, or create a volume out of it and attach it to a machine, you will get in your CloudTrail as the owner of this resource, you will get an event that says someone did this. And there are even guard duty alerts that alert you about this action because they know that this is an attack vector. We contacted AWS for this matter, and we told them there is a visibility gap that we need to bridge. They acknowledged it, and they told us they created a ticket, but nothing so far. But we are here to talk about what we can do and not what we can do. And there are some things that we can do in order to at least know that you have or had public snapshots. So we divided it into two checks. First of all, current state. Current state is to check whether now you have public snapshot. What you can do, the first thing is to use AWS API. You can use one of those two calls, describe DB snapshot. Describe DB snapshot give you a list of all the available DB snapshot in your AWS account. And what you would need to get out of this call is what you can see under query, the DB snapshot identifier. This is a unique identifier for each DB snapshot. Then you would need to pass this identifier for the next API call, describe DB snapshot attributes, and then you will get all the attributes for each snapshot. There you would be able to see if it's exposed or not, if it's public or not. Another thing that you can do is to use AWS config. AWS config is a tool provided by AWS. It's a dashboard provided by AWS that is composed of different rules. Some of them pre-built rules by AWS, but you can also modify those rules, create new rules based on your needs. And one of these rules is RDS snapshot public prohibited. Once you enable this rule, you would be able to see under compliance if you have non-compliant resources, which means public RDS snapshots again. Another thing that you can use is AWS Trusted Advisor, which is another tool provided by AWS. It has some overlaps with AWS config, but there are some differences. For example, the cost and the granularity. In AWS config, you can create your own rules, and in AWS Trusted Advisors, it's kind of built-in. You cannot control what to show and what not. And under security, there is the RDS public snapshot panel that shows you if you have any of those. As for the historical check, you would need to use CloudTrail. CloudTrail are the logs, operational logs of AWS. You can use it through the CloudTrail dashboard, or if you send those logs to any external solution. And what you would need to search is for the modified DB snapshot attribute event. Here you can see our super duper sensitive snapshot. What you would need to search is for the attribute name restore and for values to add all. This means that this snapshot went public. Another thing that is important to know is for how long this snapshot was exposed. So you would need to search for the same event, modified DB snapshot attribute, for the same attribute name restore, but in this time, you would need to search for values to remove all, and then you understand that this snapshot was exposed between this time to this time. In the documentation of this modified DB snapshot attribute, we can see under the description a clear note that says, do not add the all value for any manual DB snapshot because that contains private information because you basically expose it to everyone. As for the mitigation, we recommend to do one of two things. The first one is quite straightforward. I'm stating the obvious, but employ least privilege permission practice. Maybe it's not easy to do, but it's important. Don't give over permissions to user or roles. Give them the permission that they need in order to do their job. This is to prevent mistakes. If someone doesn't need permission to create snapshot, to share snapshot, to modify snapshot attributes, so they shouldn't. And the second one is more specific to our case. This is also something that we found during the research. We found that if you encrypt your snapshot with KMS key, which is a key management system service by AWS that provide you the ability to encrypt resources. So if you encrypt your snapshot with KMS key, you won't be able mistakenly to share it outside. You will be able to share it with a specific AWS account if needed, but not to all. So let's talk about what we had today. We discussed about what is RDS snapshot, what is RDS public, what is RDS snapshot, and what are RDS public snapshot. We show you how easy it for an attacker opportunistic attacker to find RDS snapshot and extract the data out of them. We show you what we did in order to prove that this is a risk. This is a risk that we should all be aware that if we exposed a snapshot, even for a few minutes, we should treat it as compromised. And this is only because there is a lack of visibility that doesn't tell you if someone did anything with it. If there was a visibility and we could prove that in the time that this snapshot was exposed, no one did anything with it, it was even better. But for now, with this lack of visibility, if you go and do any of the detection methods that I showed you and you find any snapshot that was exposed, you should treat it as compromised, the data as compromised. But you might ask yourself, what now? So we recommend you, first of all, like we discussed, first of all, to check if you currently have public snapshots. You can use the API calls that I showed you. You can use AWS config, or you can use AWS Trusted Advisor. And I guess there are like more tools. If you use the CSPM, you can also see those this type of information. But it's important to know if you have those. In 1 week, access your CloudTrail, access the logs, filter for the modified DB snapshot attribute event, and check if you had the public snapshot. And in 1 month, try to mitigate the risk. We recommend you to encrypt the snapshot with KMS key. So even if someone tried to do by mistake, try to share it, they won't be able to do it. Thank you very much. If you would like to have more information about the research that we did, more numbers, more juice, you can scan this QR code. Thank you.